These are notes on increasing, decreasing, and extrema. So we're going to start with an opener. So you can go ahead and pause your video and try the first two problems on your own and see how you did. All right, so if you look at the directions on the opener, it's find the domain, the y-intercept, and an x-intercepts for each function. So we'll start with this one. We're going to start with the domain, and we're going to ask ourselves, are there any restrictions? There's a denominator, and denominators cannot be equal to 0. So x plus 1 cannot be equal to 0, so therefore x cannot be negative 1. So now we want to write that in interval notation. If it can't be negative 1, it means it can be anything less than negative 1 leading up to negative 1, and then anything greater than negative 1. All right, so that is our domain. That's one thing that we were asked for. The next thing we were asked for is our y-intercept. To find our y-intercept, we know that's when x is 0. So we will plug in 0 for x and see what we get for y. If we plug in 0 in the numerator, we get 0. If we plug in 0 in the denominator, we get 1. 0 divided by 1 is 0. Therefore, our y-intercept is 0, 0. Last but not least, it asks us for our x-intercepts. Our x-intercepts we get by setting our y value equal to 0. So in this case, I'm going to set g of x equal to 0 and solve. I have 0 equals 2x over x plus 1, and now I have to solve this equation. There's multiple ways to solve this equation. Right now, what I notice is I have a fraction on the right-hand side of my equation and not a fraction on the left-hand side. So I can make it a fraction by putting it over 1. So now I have now I have two expressions that are both fractions set equal to each other. This is called a proportion. So to solve a proportion, you cross multiply. So that's what I'm going to do. I'm going to multiply these two. 1 times 2x is 2x equals, multiply these two, 0 times x plus 1 is 0, and divide both sides by 2, and I get x equals 0. So I have an x-intercept of 0, 0. So you could also remember another way of doing this is that in order for, if you went back to the original here, let me erase my over 1. I have a fraction set equal to 0. In order for a fraction to be equal to 0, the numerator has to be equal to 0. So another way of doing it is saying, oh, my numerator just has to be equal to 0. Okay, so that problem's done. Now we are on to the last one. First off, domain. I look for any restrictions. There aren't any. So my domain is all real numbers. No fractions, no denominators, and no square roots. Okay, so now I'm going to find my y-intercept by plugging in 0 for x. So I have 0 cubed minus 4 times 0, which is 0. So I know my y-intercept is 0, 0. All right, last but not least, set h of x equal to 0, and I get 0 equals x cubed minus 4x. All right, I need to solve this. First thing I ask myself is, I definitely can't solve by square rooting because there's not an x squared in it at all, right? So now I want to ask myself, can I solve by factoring? I look first for a GCF. There is a GCF of x. I'm going to pull that out. And now I can keep factoring if I want. I can say x squared minus 4 factors to x plus 2 times x minus 2, then set each factor equal to 0. Or I know how to solve both of these equations right now if I set each one equal to 0. So that's what I'm going to do. X equals 0, x squared minus 4 equals 0. First equation solved. Second equation, I'm going to add 4 to both sides and then square root. Don't forget to do plus or minus. X equals plus or minus 2. So now I have 3 x-intercepts. I get 0 for x when I plugged in 0 for y. I get 2 for x when I plugged in 0 for y, and I get negative 2 for x when I plugged in 0 for y. And yes, you can write those last two ordered pairs as plus or minus 2, 0. Plus or minus 2, comma 0, because that's saying both 2, 0 and negative 2, 0. Okay, let's move on to our notes here, which once again is on increasing, decreasing, and extrema. So first off, it says here, an analysis of a function can include a description of the intervals on which the function is increasing, decreasing, or constant. So it says consider the graph of f of x shown. That's the graph to the right there. As you move from left to right, f of x is. So whenever you're looking for increasing, decreasing, and constant, you are moving your eyes from left to right, okay? All right, so we're going to look where it's increasing. So increasing would be if you had to travel on it that you were going uphill. So look from left to right with your eyes. This part right here is considered uphill, okay? So now I'm going to write the interval on which it's increasing. The interval is the domain, okay? So that's what we're looking at. So we will look at this, the domain of this one. Let me change colors here so we can actually see it. It starts right here, which is an arrow pointing to the left. And if you're like it's pointing down, remember I'm looking left to right. I'm not looking up, down to up. So it's pointing to the left here, and that's negative infinity. And then I'm going to say where it stops. And if you look, it stops right here, which is -5. And we are using a parentheses. I'll explain why in a second, but we are using parentheses on increasing, decreasing, constant always. No brackets. Brackets can only be included in domain and range, not on intervals for increasing, decreasing, and constant. All right, let's move on to constants. So it is a constant when it is flat. So here it is flat. It's going, if I look left to right, I already have the dash line there for left, and then it stops there on the right. So it's from -5 to 0. So it is constant from -5 to 0. Once again, remember you're looking at the domain of that piece. Last, it's decreasing, which is downhill right here. So we're going to look left to right. Starts decreasing at 0, and it stops decreasing. It never stops decreasing. It goes on forever and ever. So 0 to infinity. All right, so pretty easy. So it all explains right here what increasing, decreasing, and a constant are, but I think it's pretty self-explanatory. Uphill, downhill, flat. All right, so this is what I was talking about with the parentheses. So this is our special note here. Notice it's bold, it's box, it's starred, it's important, right? So it says when writing an increasing, decreasing, or constant interval, by definition, it is on an open interval. So it is open. If it is open, that means we're using parentheses. Closed would be brackets. So by definition, it's open, okay? All right. Therefore, these intervals will always be written with parentheses and never with brackets. Okay, so increasing, decreasing, constant, only parentheses. Domain and range can have brackets and parentheses, or just brackets. Okay. Next, we have a little bit of vocab, and then we'll get into the practice, and you'll see you can be pausing the video and trying on your own. So first off, we have to talk about the difference between a relative maximum, a relative minimum, an absolute maximum, minimum, and a point of inflection. So relative maximum, when you're looking at the graph, it's the value of f of x when a function changes from increasing to decreasing, okay? So the value, I'm going to try to write this nice because I'm going to end up copying and pasting, of f of x when a function changes from increasing to decreasing. Okay, so that's in words. I want to make sure you understand it as I'm drawing a picture here. So the value of f of x when a function changes from increasing to decreasing. So watch, I'm going to go from increasing to decreasing. So the value right there of that f of x value, the y value, let's make sure we understand that that's what that's saying. The y value of when it changes from increasing to decreasing. So you're looking from increasing to decreasing, that's a relative maximum. And it's whatever the y value is. It's not the ordered pair, it's the y value, okay? All right, relative minima is the same idea, so I am going to copy this to save myself some writing and some time, or duplicate it. Why not? Duplicate. I'm going to put it for the relative min, but I do have to change these two words right here because it's obviously from decreasing to increasing. Well, that's not what happened there. Decreasing to increasing. And then that y value, whatever that is your relative minimum. So this is from decreasing to increasing. And once again, it's the y value. All right, so if we look at this little sketch right here, by looking at this, I can see that there's one relative maxima because it goes from increasing to decreasing at one value right here, at one point. Whatever the y value is, that's your relative max. And then I can see that there's two relative minimas, right here and right here, because notice it goes from decreasing to increasing, decreasing to increasing. If I say what's a relative maxima, some people will try to give me this y value right here, which is infinity. No, it's not going from increasing to decreasing there. It's not decreasing at all, okay? All right, absolute maximum, absolute minima. So if you look at this, the absolute minima would be out of these two values right here, it would be the lowest y value, the least y value. The absolute maximum would be the greatest y value out of your absolute or out of your relative maximums. So we're going to write the greatest for relative maxima or least. I'll put slash instead of in parentheses. Least value f of x reaches in the entire domain. Okay, last but not least, a point of inflection. A point of inflection is when a graph changes shape, but not whether it's increasing or decreasing. So we're going to say graph changes shape. But not increasing to decreasing or vice versa. And we're going to draw a picture of what that looks like to make sure you understand, because some people are visual people, right? All right, so if I was increasing, okay, but then the graph's going to change shape. It's not going to go to decreasing. It's not going to go to a constant. It's going to continue to increase, but the shape's going to change. So let's say I went like this. It's still increasing. This right here is not a relative minima. It's not a relative maxima. It's a point of inflection. It went from increasing to increasing, okay? All right, so now we have examples for the rest of these, and then we do, I believe, have a calculator problem at the end, so you will need your calculator for that. Okay, so increasing, decreasing, constant, for example, when I want to know the intervals on which that's happening. So let's do all the increasing first. I will color code these. I'll do pink for increasing. So remember, we're looking left to right, and we're looking for uphill. So this right here is uphill, left to right, uphill, no more, all right? So now I'm going to state that interval on which it's increasing, which is the domain. So if you look right here, that's -2 to 0. All right, now we're going to look for decreasing. Decreasing, I'm looking for left to right, and it's going downhill. So that's this. It's not like perfectly downhill, but it's getting smaller. The y values are getting smaller and smaller. Same thing here, that's decreasing. So I have two intervals. So I have from here to here, which is -4 to -2. Also, so union. And then I also have this piece right here, which starts here, ends here. That's 0 to 1. Last but not least, I'm looking for constant. Ooh, I should probably highlight this to show that. I'm looking for constant. So where it like is a flat line, basically. And if you look, it's constant right here. And I want the domain of that piece. So that starts at 1. And then there's an arrow pointing to the right, which means it goes on forever and ever. Notice I use parentheses on all of these. Next, it says find the relative or local minima. We put the local in parentheses. Some books say local, ours does not. So we're going to say relative minima and our relative maxima of the above graph. So the relative minima, let's do min, relative maxima. So there's only one answer for each of these, even if the graph dips twice or has a hill twice. We're looking for the absolute, okay? Oh, no, this one is the relative, so all of them. My bad, I read it wrong. Okay, so I'm looking for relative min, where the graph goes from decreasing to increasing. So on mine, it'd be going from yellow to pink, which is right here. I'm not going to say the point -2, 0. I say the y value, which is 0. Now I'm looking for a relative maxima, so anytime it goes from increasing to decreasing. So that's when it goes from pink to yellow, and that is right here. Once again, I'm not going to say the point 0, 2. I'm going to say the y value, which is 2. Okay? All right. So we have two examples here. I would, if I were you, pause the video, try doing it yourself. These are nice, good practice problems, and then come back and check to see how I did. You can fast forward the video to the end and then just, pause it and see if you got all the answers right. If you didn't get something right, rewind and look for my explanation. Okay, so my domain, so I'm going to look left to right. Okay, so it starts here. That has an arrow pointing to the left, so that's negative infinity, comma. And now I'm going to keep looking to the right. Some people will say it stops here. No, it doesn't. It's just a really defined point because we want you to be able to tell where it is. It doesn't stop there. Keep going, keep going, keep going, keep going. Right here, that is a hole in the graph. Okay, it's not a jump. There is a hole there. There's no x values at -2. So I'm saying stop at -2. There's nothing there. And I'm putting a parentheses because there's nothing there. But then the graph does pick up right away at -2. And we're going to keep going. Once again, the graph does not stop at this value. Okay. Keep going, keep going, keep going. And then I see a stop right here. I got to make sure there's no arrows pointing to the right anywhere. There aren't. I'm going to say what y value that stops at, and that is 9. All right. This time, I do not like that 9, so I'm going to try again. All right, this time I look and there is a x value at 9. So I'm including 9 with the bracket. I'm going to erase all this green here and I'll do the range. So I want the lowest my graph goes. So with my eyes, it looks like the lowest the graph goes is here. I got to make sure there's no arrows pointing downward. There are not. So I'm going to say the lowest my graph goes is -6 and there is a y value there. So bracket, comma. And now I'm going to look up. And I say, okay, there's y values here, there's y values here, there's y values here. And then all of a sudden I see an arrow pointing up. That means that there's y values forever. A common mistake people will do is they'll say it stops right here. And they'll say it goes to 9. It doesn't go to 9 because of this arrow pointing up. It goes on forever and ever. So infinitely, parentheses. Another thing people will accidentally do is they will say, oh, and there's no y values at 2. Yes, there is. There's a y value at 2 here. There's a y value at 2 here. There's y values at 2. So you don't disinclude it. All right, is the graph even, odd, or neither? If it was even, it had symmetry over the y-axis, which it does not. Odd, it had symmetry about the origin, which it does not. So this is neither. Where is it increasing, decreasing, or neither? So we'll start with increasing. Increasing, looking left to right. Hold on, I did not want that. There we go. Increasing left to right, right here. It's increasing here. So it's increasing on 2 intervals. I'm going to write both intervals. So that is from -5. Nope, my bad. Let's see that again. That's -6 right here. Sorry. -6 to -2. That's not -2 either. Yes, it is. Oh, I went too far. That's why. -6. Let me go back there. I was like, that doesn't seem right. Because it stops right there where my green line stops. -6 to -4. Remember, parentheses only. And then where's my other increasing that I got rid of on accident? Right there. Okay. And then the other one is -2 to 3. I'm going to say union, -2 to 3. All right, decreasing. So decreasing, looking left to right, downhill right there, right here, and right here. So I'm going to have 3 intervals. All right, so here to here, which is an arrow to -6. That's negative infinity. Oops. Negative infinity to -6, union. And then this one starts here. Oops, I accidentally did the green piece instead of the yellow piece. -4 to -2. And then there is one more piece where it's decreasing, and that starts at 3 and it stops right here at 9. So 3 to 9. I've made a mess of this graph. I'll get rid of all this. All right, last one on the increasing, decreasing constant is a constant. And if you look, there is no flat horizontal lines. So there's no constant. It's okay to not have any of them, right? All right, relative min and relative max. So I wish my yellow and green was back. So I'm going to go backwards and bring it back. Okay, I'm going to get rid of these red lines, though, because they're bothering me. There we go. Okay, and I'm going to write constant was none again. Okay, so relative min, I'm looking for it going from decreasing to increasing. So that's anywhere it's going from yellow to green, which is right here. Yellow to green, right here. Okay, and nowhere else. Okay, so I have 2 relative minimas, the y value at which it's going from increasing to decreasing. So that is -1 and 2. And we have to talk about that 2 part. So let's talk about the 2 that I just wrote down, okay? So, oh, I keep erasing the wrong part, but it's okay. Bring that back, that 2 that I colored in there. Notice that there is no value there. And the definition is the value at which it goes from increasing to decreasing. And there is no value there. So we actually do not have a value at 2. So there is only one relative minima, and it is at -1. Okay? All right, now let's do relative maxima. Relative maxima is where it goes from increasing to decreasing. So green to yellow. Green to yellow is right here. I want to circle it instead because coloring it in almost made me include 2 on the other last one. Okay. Well, I can't unerase it, so I'm just going to leave it. All right, increasing to decreasing. Increasing to decreasing. So we have 2. They're both points there, so whatever the y value is. That's 5 and 9. Okay? All right, so common mistakes people make. They'll say this is a relative minima, or they'll say this is a relative minima, which neither one are. Okay. Next one, go ahead and pause the video and try on your own. All right, your domain, -5. That's where your x values start. And then, if you look, they keep going. They keep going. I should probably be highlighting and just instead of saying it. So start here. Keep going. They do not stop at this red because notice they pick right back up. Keep going. There's still x values here. And then they stop here. Now, people will say there's a jump, so it keeps going. That's not a jump. Jumps are vertical. Notice that's on a diagonal. So the graph does stop there. The x values stop at 1. So I'm going to say the x values stop at 1, and there is an x value at 1. Okay? Now, where do the x values pick back up? They pick back up right here. Is there an x value there? No. So we're still going to write down the 2 that it picks back up at 2. It's just that we're not including it. So we're going to put, oops, I put that in the wrong spot. So we're going to put a parentheses on it. So I'm going to say union 2, and it picks back up, and then it keeps going. There's x values here, 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 and then they stop at 5. Notice there's no arrows on this graph, so I don't have to worry about infinities. Bracket on my 5 because there is a value at 5. All right, let's do range. Lowest it goes is right here at -2. There's no arrows pointing down, right? So I look up, there's y values here, 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 here. Some people accidentally say there's no y values there. Yes, there is. There's a y value at 1 right there. Keep going, keep going, keep going. Some people accidentally stop it there. Nope, y values keep going. And then y values stop at that max right there, which is a 4. So we're going to say from -2 to 4 is your range. Even, odd, or neither, there's no symmetry here at all. There's no symmetry over the y-axis or about the origin. So this is neither once again. Increasing, so I'm looking for where the graph left to right is uphill, which is right here. No more increasing. So the domain of that piece, it starts at -2 and it ends at 0. So -2 to 0. Remember parentheses on this. Decreasing, it's decreasing right here. And then it's also decreasing here. These are 2 separate pieces. Remember, the domain of them is not continuous. There is not a jump there, but there is it ends and then picks up at a different x value. So make sure you say them separately. This is 0 to 1, the first piece, that little blue part. And then the second piece is 2 to 5, union 2 to 5. Last but not least, a constant, which is this red piece right here. And it is constant from -5 to -2. Relative min, we're looking for where it goes from decreasing to increasing. So that'd be from green to yellow, which does not happen, none. Relative max, increasing to decreasing, yellow to green, it does right here. The y value there is 4. Okay. All right, last but not least, we have a calculator problem. Let's hope that my calculator is still here. Let's see. Yes. Oh, come on. There we go. Oh, that's ginormous. There we go. Okay. All right, so it says use your calculator to find the following information. So we will do that. Where did my calculator go? Hello, there you are. Okay. All right, so we need to first put our equation, which is right about there, into our calculator. I'm going to clear all this stuff out here. We're going to go to y equals. We're going to clear out anything that's already typed in there, and then we're going to type x to the fourth power, get out of the exponent, minus 5x squared plus 2. Okay, now I want to graph this. I have no clue what the last thing I graphed was, so I'm going to reset it up to the negative 10 to 10, negative 10 to 10 by hitting zoom standard, which is zoom 6. And I can see the graph. That's wonderful. Okay, so I'm going to do a sketch of it now. Rough sketch, that is. All right, so I know that it hits the graph like here-ish and symmetrically here-ish. And then also about here. And then I'm going to do my best, okay? All right, so here we go. Oh, that's not good. Why do I say it's not good? Because these, on the graph, the y values look like they're the same of those two mins right there. And on my graph, it doesn't. So I'll try one more time. Maybe I'll go a little faster and it look better. Okay, we're going to leave it like that. Okay, there's my sketch. All right, I want the domain first, okay? Notice I put arrows on the ends because the calculator screen just cut it off. It keeps going forever and ever. So looking left to right, my domain is negative infinity to positive infinity, arrow to an arrow. Now I need my range. I need the lowest my y values go. So this is the lowest the y values go. So I need to know what those 2 points are right there. So what I'm going to do is I'm going to get those 2 points from my calculator. I can clearly see that they're symmetric, okay? But I could also pretend like I don't know they're symmetric, okay? All right, so let's get where those points are. So if you look what those are minimums. So if we go to calculate, which is right above trace, it's the blue letters right there, C-A-L-C, above the trace button, which is the fourth button on the top. I want to hit calculate. So I'm going to hit second and then the trace button. Option number 3 is minimum. So we're going to choose that. And now we want to find the minimum. So what we're going to do, it says, if you look at the bottom of the calculator screen, it says I want a left bound. So I want to get to the left of that minimum. Oops, I went too far. I'm still to the left of it, but still. All right, so I'm to the left of it. I'm going to hit enter. Now I need to get to the right. So I'm going to toggle so I'm to the right. All right, I'm to the right of it. I'm going to hit enter. And then it says, should I guess? Hit enter one more time because they were saying yes, please. So this point right here is negative 1 point. Now that keeps going, that decimal, so if we need to round at any point, it's always 3 decimal places. So we're going to say 581, comma, and then negative 4.25. All right, now this point is clearly symmetric, so I know it's just positive 1.581, comma, negative 4.25, but just to show you that it is, second trace, option number 3 is minimum. I'm going to go find that other minimum. I'm going to toggle until I'm to the left, oops, too far, of that minimum. Enter, hit to the right. All right, I'm to the right, hit enter. And as you can see, it's 1.581, comma, negative 4.25. All right. So the lowest my graph goes, is these these y values right here, which is negative 4.25. Oops. There are values there, so bracket. And then if you notice, it goes on forever and ever. The highest it goes right here, infinitely. Even, odd, or neither. Don't look at my graph for that. Look at the calculator for that. And you can see that there's symmetry over the y-axis. So this is even. All right, now we want to know where it's increasing. So let's highlight those pieces where they're increasing. Let me get rid of my highlight here. So where is it increasing? I'll use yellow to highlight. It's increasing from here to here, and it's increasing from here to here. Okay, so I want those 2 domains. So I know that this domain, this first piece that's getting more yellow as I trace it here, is negative 1.8, sorry, negative 1.581. And then it looks like it stops at 0. So let's find that point just to make sure. So that is a maximum. So we're going to do second trace. Option number 4 is maximum. We want to get to the left of that maximum. There we go. Enter, get to the right of that maximum. Here we go, enter. And then it says, ooh, this is a good little lesson here. It says negative, let me write it down, 1.382e, negative 6. This is scientific notation. It means move this decimal place 6 places, 1, 2, 3, 4, 5, 6, to the left and fill those in with zeros. So if you look, it's negative and then this teeny tiny number. This is a pixelation error. That's just 0. So whenever you see that in your calculator, that's 0. So this point right here is 0, 2. Yours might say 0, 2, but then next time it might have an E in it. So just make sure you're listening to that. Okay, so now I can say the domain of that piece is negative 1.581 to 0. Union my other piece is 1.581 infinitely. Where is it decreasing? I will highlight that in green or orange, whatever. Decreasing here and here, okay? All right, so that's from negative infinity. And then it stops decreasing at negative 1.581. And then it's decreasing also from 0 to 1.581. All right, so the calculator stuff is not that bad. You just have to find these points. Where is it constant? Nowhere. There's no horizontal lines there. Relative minima. So we're looking for minimums. There's a minimum here and here, and we want the y values, which is negative 4.25 for both of them, so we don't have to list it twice, negative 4.25. And then we're looking for a relative maxima, so where it's going from increasing to decreasing, which is right here, and we just want the y value, which is 2. All right, that's it for today's notes. You can go ahead and get started on the homework.